We are in chapter 3, linear systems, and the section number is also 3, and the title is also linear systems. We consider a homogeneous linear system of differential equations written in the form of y prime equals p of t y, where p is an n by n matrix with entries that might be functions of time. And the solution we are looking for is a vector-valued function y. In general, this function has n components, but in this class we are only interested in a two-component vector, which means that the system has two equations. The reason for this limitation is that systems with 3 and 4 components are much harder to solve than systems with 2 components. In fact, systems with 5 and more components are impossible to work out on paper in general. In these cases, computers are used to approximate the solution only. So the theory for a system of two differential equations, y prime equals to p of t times y, is that the general solution can be written as c1y1 plus c2y2. If y1 and y2 are fundamental solutions, which is the case if and only if y1 and y2 are linearly independent. And this is the case in turn if and only if their Wronskian is not identically zero. The Wronskian of the y1, y2 vector solutions are defined as the determinant of the matrix that you get when you put together the two column vectors y1 and y2, and then you get a matrix. So you calculate its determinant, and this shouldn't be identically zero. So in this case, when you write the solution y as c1y1 plus c2y2, you can also write this as a matrix vector multiplication. The matrix is the y1, y2 vectors put together, and the vector is the column vector that we get when we put together the c1 and c2 coefficients. Next, we will see how it works through an example.